Hello everyone, this is the lecture for section 1.1, Functions and Functions Notation. So, we need to start pre-calculus by defining certain things. And what we're going to do first, absolute foremost, the very first thing we have to do is define what a function is and how to play around with it. So that's what section 1.1 does. We're going to define functions and how we write them down, okay? So here's some learning objectives that we're going to be doing, right? Determining whether a function is a relation, okay? Finding values of functions. It's not too important right now, but it will become important in the later sections. Figuring out is a function is one-to-one. Vertical line tests to identify functions. There's a quick way to do it, vertical line test. We'll get there by the end of the section. And graph functions listed in the library of functions. This is going to be something that we're going to be, the last bullet point is something that we're going to be sort of carrying on throughout section, chapter 1, sorry. Okay, so let's go ahead and start. I want to first go ahead and define what a function is, okay? A function is a relationship, right, between two different sets of stuff, okay? And this is the important thing, right? Each possible input leads to exactly one output. The important word here is the exactly. There's only one output for every input. Okay? Cool. We say that a function is the output, right, of the input. So if we put something in, the function puts something out. Okay? The set of all inputs is what we call a domain. And the set of all the outputs is what we call the range. Okay? So this sounds a little complicated, right? So it's best, like I said when I was explaining the syllabus, it's best to explain it using sort of little blobs. Okay? So, for example, this one right here for number A, for letter A, that is a function. Notice that every single input, every one of my inputs goes to exactly one output. Okay, it can go, so each input can go to one output, but at least each input goes to exactly one. Okay, now this it sounds a little confusing. You know, run this out with me. All right. For B, this one seems a little bit more easier, right? All of the inputs, they go to exactly one output. Okay? Okay. This one, though, this very last one, I'm going to do it in red. It is not a function. Okay? So if you take a look, here's my set of inputs, right? And let's go ahead and take in particular, a look at Q here, right? Q goes to two outputs, right? This right here is what messes it all up. This right here is what screws up our definition of a function. So because Q goes to two outputs, right, the relationship for C is not a function. Okay, so the thing that you have to remember, right, is that each input, right, goes to exactly one output. Okay, so let me go ahead and start doing, let me start sticking in some numbers, right? So for this example, okay, to determine if it's a function or not, right, we have to determine that every input goes to one output, okay? So we can do that using our blobs like we did before, okay? So if we do two little, right, our inputs are going to be 2, 5, 8. Our outputs are going to be 1, 3, 6. And if you take a look, right, the 2 goes to 1, the 5 goes to 3, and the 8 goes to 6. This one's good. No problem. Got it? Okay. Let me do one more. Okay. Same thing. I'm going to make my two blobs, right? -3, 0, 4. Okay. Notice how my my outputs are going to be just 5 and 1, right? But if we take a look, so negative 3 goes to 5, 0 goes to 1, right? And 4 goes to 5. Okay, this is still fine. Each input goes to exactly one output. Okay? Okay, I will leave this one for you guys to try, but I do want to try this last one to sort of hammer out the idea. Okay, I'm going to do the same thing. So notice my inputs are just 1 and 5, and then my outputs here are going to be 0, 2, and 4. Okay? 1 goes to 0, 5 goes to 2, and 5 goes to 4. There it is. This right here is what messes it up. So this one's the, nope. So that last one is not a function. Okay? Now, we kind of figured out how the relationship goes. Okay? Now we have to write in how, in particular, how we're going to write this down on pen and paper. Okay? And that's the function notation. The notation that we're going to use is this right here. When it does, when we write down y is equal to f of x. Okay? The way that we read this out is we say that y is a function of x. So that means my x is my input values, right? Or what we call the independent variable. Okay? And the letter y represents our output values, or the dependent variable. So the idea here, right, is that the y value depends on my x value. Okay? X can be whatever it wants, right? And whatever x is, that dictates what y is. Okay, so that's why we read it as y is a function of x. Okay, so now how do we actually use this? Okay, that's example 2. Okay, for example 2, right, let's say we want to use functions notation to represent a function whose input is the name of a month and the output is the number of days in that month. Okay, so this is the part you're going to be a little bit afraid at the very beginning. Okay, but you'll pick it up as the semester goes along, right? Whenever you need to define a function, you can call it whatever you want. Okay, so long as you use the notation that's been presented up in our definition. Okay, so what I mean is this. So let's take this example right here. Right, I need a function where if I give it a month, it'll give me the number of days. Okay, and just keep in mind for right now, okay, this is just how to write stuff out. Okay, there's no function for this. I'm not going to throw in math yet. Okay, so let's say I want to write a function that if I give it a month, it gives me out the number of days. So I can go ahead and call it this, right? N of m is equal to some value d. Okay, and the way that we say this is this. So m is equal to the month name. Okay, n of m, so if I plug it into my function n, it's going to spit out a d value, right? And d value is going to be the number of days. Does that make sense? So when we want to specify something mathematically, right, this is how we would do it. This is how we would do it, okay? All right, so now let's get into actual mathy stuff, okay? Now I'm going to start throwing in mathematical like notations and stuff like that, okay? So let's go ahead and get to evaluating functions, okay? We now know how to write functions, right? And it's a very compact, very efficient way of writing stuff down, right? But it gets confusing sometimes, right? We have to get through it, though. We have to get through it, okay? In order for us to do that, okay, something that I've seen a lot of students struggle with is some algebra skills that I want to cover right We're going to save this for our in-person time for us to do as a class. Okay, but I will do the example here. Okay, the first thing that I want to cover is FOIL. Okay, that's the sort of the acronym that probably most of you guys remember from high school. Okay, first, outer, inner, last. Okay, when we multiply two things together, okay, when we multiply two monomials together, okay, it's in this fashion right here. This looks super complicated, but it's better if I work it out so you guys can see. It's exactly the same thing that you will remember from high school. Okay, so let's say I wanted to perform this following operation, that I wanted to expand this, that I wanted to multiply both of these things together. Okay, the way that you would do it, hopefully you guys remember this. Like I said, it's from high school, right? Firsts, outers, inners, lasts. Okay, so let me go ahead and do the multiplications out. I'm going to say them out loud and then do them, and I'm going to write them out separately and then combine them all together. Okay, so the first, it's going to be 2x times 3x. So I'm going to write those out. So it's going to be 2x times 3x plus outers. So that's going to be my 2x and 1. So it's going to be 2x times 1 plus inners. That's my 3 times 3x. So it's going to be 3 times 3x plus, and then now the last, 3 times 1. Okay. Now I'm going to do the multiplication in each one of these. So 2x times 3x, that's going to be 2 times 3, that's 6. X is x squared, so it's going to be 6x squared. Okay. 2x times 1, that is going to be plus 2x. 2x. 3 times 3x, that's going to be plus 9x. And then 3 times 1, that's going to be 3. Okay? Okay. I can reduce this now. 6x squared, that can't reduce anymore, right? So 6x squared, I'm going to rewrite that. But I have these two right here. 2x and 9x. So it's going to be plus 9 plus 2x, 11x plus 3. This is my final answer. So if I need to multiply these two things out, this is what it would be. Okay? Now, why did I show this to you guys? I sometimes in math, actually a lot of times in math, you need to be able to evaluate things using my functions. Okay? So that's what I'm going to do right here. I'm going to show you guys how to do the evaluation of something using functions. Okay? So for this example, I have my function. This is my function right here. Okay? And I need to evaluate it at 2, a, and a plus 1. Okay, so let me do f of 2 first. So when I need to evaluate at 2, that is basically saying I need f of 2. I need to plug in 2 everywhere I see an x. Everywhere I see an x. Okay, so then that means it's going to be 2 squared plus 2 times 2 plus 1. Okay, notice that everywhere there is an x, there is now a 2. That's the point behind evaluation. Okay? Okay. 2 squared, that's going to be 4. Plus 2 times 2, that's going to be another 4. Plus 1, that is 8 plus 1, 9. Okay, that is it. We are done. We evaluated f of 2. Okay? Next one. A. This one's going to be simple. F of a. This is just to sort of prove a point. A squared plus 2a plus 1. That's it. We are done. This is it. This is, like I said, it's to prove a point. It's to show a point. This notation that's right here, right, tells you that you are grabbing a function and plugging a said thing into it. That is it. Okay? The last one is the one that's a little bit more difficult, but that's what we need the algebra for. So, f of a plus 1. Here we go. So this is telling me, in my function, anywhere I see an x, I put in an a plus 1 instead. A plus 1 squared plus 2 times a plus 1 plus 1. So notice that everywhere I'm going to do the there's an x, there is now an a plus 1. Okay? All right. Here's where we need our algebra. Okay? I need this thing to be expanded, and I need this to be expanded. Okay? So I'm going to do it over here. A plus 1 squared is equal to a plus 1 times a plus 1. Since I'm squaring it, I have to multiply it by itself, right? All right, here we go. First outer inner last, so it's going to be a squared plus a plus another a plus 1. The middle two, they collapse, right? A squared plus 2a plus 1. Okay, so we have this bit. Okay, 2 times a plus 1. This one's a little simpler. This one's just you multiply the 2 into both of them. This is probably something you remember from, what, the very first year of high school, probably, middle school, right? So 2a plus 2. We have all our bits. We get to go ahead and collapse it all down. So the a plus 1 quantity squared is this thing right here. A squared plus 2a plus 1 plus this thing right here is this thing right here. So we now have 2a plus 2 plus 1. Now we get to combine all this stuff together. Okay? The a squared, there's not another a squared, so we just go ahead and do a squared. Plus, here we go. There's a 2a here and another 2a there. If we combine all of them, we get 4a. Okay? And then the last thing, we have plus 1, plus 2, plus 1. Okay? So 1 plus 1 is 2 plus another 2, that is 4. So it's going to be plus 4. Okay? And we are done. This is our final. Okay? So that's it. This is how we use functions notation. This is how we use functions notation. Okay? Okay, next thing up is our very first quick check. Okay, we'll do this during our class time. Next thing I need to cover, something that I think we need to all cover, is, let me get this centered nicely. Come on. Oh, okay. Next thing we need to cover is an algebra skill. Some of you guys might remember this called the diamond method or reverse foiling. The mathematical term is factoring. We're going to factor simple quadratic equations. This is something that we're going to be using on a regular basis throughout the course. Okay, so hopefully you guys remember this. I'm going to cover it. It sounds super complicated, like I said before, right? But it's something that you guys should remember from high school. Okay, so suppose you had a simple quadratic function like this. Okay, some x squared plus some bx plus c. B and c can be any numbers you want it to be. Okay, we can factor this. Okay, so you remember how we did foiling. We had two separate things. We multiplied them together to get one more complicated thing, right? This is going to be the reverse of that. So we're going to have a complicated thing, and we're going to factor it out into the multiplication of two different things. Okay, So how do you do it? Okay, so here's an example. Suppose this is our function, okay? And I want to split it back up into two multiplications, okay? Suppose I want to split this back up into two things that are going to be multiplied together, okay? This is where this diamond thing came from, okay? So hopefully you guys remember this, or the X method, or I can't remember what else it's called. I remember it as the diamond method. Actually, you know what? Let me move this over here so make it nice and big. Whoosh. Okay, there we go. All right, I'm going to do this. This is going to be my times. This is going to be my plus, okay? The times has to be equal to my negative 35. And my plus has to be equal to 2. Okay, so minus 35 plus 2. I need two numbers. I want you to think about this. I need two numbers that multiply to negative 35 and add to positive 2. Okay, those two numbers are plus 7 and minus 5. Okay, that is it. So what happens here is this. You guys see these two numbers right here? I'm going to highlight them in green already. X plus 7, x minus 5. And we're done. That is it. Boom. Okay, so if you grab this thing and FOIL it out again, okay, you get this. You can see how sort of useful this is. We get something really complicated, and we're turning it into something a little simpler. The product, the multiplication of two separate things. Okay, that's what makes this so nice. Okay, let's move on. We'll leave the examples for our class time. Now, the reason why we need this, okay, is for this right here. So what I'm going to do now is, suppose we had a function. We know how to evaluate a function. Okay? We know how to evaluate a function. But sometimes we need the value, right? We need the value that needs to be evaluated to get a specific result. Okay? So, and in this case, if you take a look at this, right? You see that? Before we know what to do if that 20 was inside where the x is, right? But we don't know what to do if the f of x is equal to 20. We want to find, okay? We want to find that x value, right? Such that when we put it into f of x, we get 20, right? How do we do that? Okay, that's where we're going to use our algebra skill from before. Okay, so we need f of x is equal to x squared minus 5x minus 16. We need this equal to 20. Okay? All right, here we go. I am going to look at this thing only. Okay? I'm not going to worry about that right now. I'm just going to look at x squared minus 5x minus 16. We need that equal to 20. Okay? I am going to go ahead and do this. Minus 20 minus 20, x squared minus 5x minus 36 is equal to 0. Okay? Now, I'm going to use something that we're going to be using on a regular basis. This is not really an algebra thing. This is just sort of like a numbers thing. Just keep this in the back of your mind. Okay? So what I want to do is this. And I want to run through the idea behind it. Okay? Let's say I had an a times a b, and it's equal to 0. A and b can be any numbers you want. Okay? But I multiply them together, and I get 0. Okay? What can you tell me about one of those two numbers? So if you have a product, if you have an A times a B, and it's equal to 0, then either A is equal to 0 or B is equal to 0. Okay? It's got to be one or the other. It's got to be one or the other. Okay? So here's where this is going to work out. So suppose we had, let's go back to this, our example right here. Right? We have something that's equal to 0. Okay? I'm going to do my diamond method on this. Okay? Times plus, if you guys remember, the times has to be negative 36 and the plus has to be negative 5. So I need two numbers that will multiply to negative 36 and add to a negative 5. Okay, a little bit of thinking for yourselves. That's going to be minus 9 and positive 4. Okay? Okay, so then that means, going from our example from before, we have this, x minus 9, x plus 4. Both of these things, this right here and this right here, are exactly the same thing. If you want to FOIL it out, go ahead. Okay, but here's where we're going to use this thing right here. Okay, we have a product. We have something times something equal to 0. That means either the first thing's got to be equal to 0 or the last thing's got to be equal to 0. So we're going to use that. Okay, so that means either x minus 9 is equal to 0 or x plus 4 is equal to 0. And if you guys do the simple little math here, x is equal to 9 and x is equal to minus 4. Boom, boom. So what did we just find? So for both of these, right, if I grab x equal 9 and plug it into f of x, I get 20. If I plug in negative 4 into f of x, I get 20. So what we have here now is at least a little bit of an understanding of, if I want my function to be equal to something, right, what should my input be to get that output? Got it? Cool. Okay. Quick check number 2. We'll do this in class. Okay. Now let's go ahead and tie in, like, let's say we get graphs with these, right? Okay. All of these functions, a lot of the functions, every single function that we're going to be working with in our class is going to have some sort of graphical representation. So we're going to be able to, throw these on on graph paper and look at their relationship. Okay. So usually, okay, when we have y, let me actually put this over here. Y is equal to f of x, okay, we tend to say this, that on this horizontal axis that goes like this, the side to side one, right, that is where we put the x values, right? And on the vertical axis, so the one that goes up and down, okay, those are going to be my y values, okay? So this is how we sort of orient ourselves when we want to sort of put these down on graphic, put the relationships of these functions down on paper, okay? So what I want to do here, right, is I want to look at both of these, okay? For each one of these graphs, I want to find f of 2, and I want to solve for f of x is equal to 1. Notice I don't give you guys functions. I don't tell you what the equations are for these functions. We're just going to do them off the graph, okay? So if we take a look, okay, f of 2 is telling me, right, it's telling me that my input value is 2. What is my output? So my x value is 2. What is my y value, right? So if my x, and I'm going to do this in in this purple. If my x value is 2, I'm going to go here. I got to see where my y value is. That's this point right here. So according to this, my y value is 1. We're done. Okay? F of x is equal to 1 when x equals what? Okay? So in this case, I know what my output value is. My output value is 1. I need to find the input value that gives me that. Okay? So my output value is 1. So I'm going to go ahead and erase this purple point. I'm going to use green here. So you guys see 1? What are the x values that do it? Now I'm going to switch back to my purple. There's 1 here and 1 here. You guys see that? So the two x values that give me my output of 1 is either 2 or 0. Both of these are perfectly valid answers. Okay? All right. Let's move on to the next one. F of 2. Write that a little nicer. F of 2. Okay. So in this case, right, same thing. My input value is 2. What's my output, right? So same orientation. This is still going to be my x values, and this is still going to be my y values, right? I'm looking at this point right here. The y for it is 0. Boom, done. Okay? If I want my output to be 1, right? So here's 1 on my y, right, my outputs. What x value does that? Right, I'm looking at this point now, right here. I'm on purple. There we go. Right there. So it's going to be 0. And done. Okay, next one. Okay, hopefully you guys see where this one's going. Okay, so in this case, okay, my input value is 2, right? So here's my input value of 2. Okay, I want the y values for it. I want the y values for it. Got it? Okay. There's one right here. There's one right here. So that's going to be what? A positive 1.5 about and a negative 1.5. That's completely fine. Okay. Now, I will bring up something right down below in a little bit. Okay. Now let's go ahead and do f of x is equal to 1, 1. So when my output is equal to 1, what is my y value? Or sorry, did it the other way around. When my output is equal to 1, what should be my input? Okay, so I'm going to go on my y. Here it is right there, right? So I'm looking at a point in particular. Okay, the only one that does it, 0. Done. Boom. Okay. So now, hopefully this one ticked you off. Okay. And in order to sort of cover this right, I need to do what's called the vertical line test for functions. Okay. We know what the definition of a function is, right? That for every input, there is exactly one output. Okay. That is the definition of a function. Okay. The vertical line test is the quick and dirty way of finding out if you have a function or not. You do need the graph, right? But it's much quicker, much quicker than going through every single value like we did before. Okay. The vertical line test says that, I'm going to go ahead and highlight it here. If we can draw any vertical line, if we can draw a vertical line that intersects a graph more than once, then the graph is not a function. Because what we have is that for every input, there's more than one output. Okay, so case in point, this last example that we did right here. This example right here. Okay, notice that there's one input and there's two outputs possible. This is not a function. Now, how does this work with a vertical line? I can grab any vertical line. So I'm going to actually do it in my orange highlighter. Okay. And I had a rule here. That's fine. You see that vertical line draw right there? It hits my graph twice. Okay. A function can hit it only once. Okay. So if I draw a vertical line and it hits my graph more than once, you do not have a function. Okay. So this third one that I have right here is not a function. The other two are. So if I draw any vertical, that, it only intersects my graph once. Okay. Same thing with my first one. Vertical lines. That one. That one. That one. They only hit it once. So I have a function. Okay. Cool. Okay. It's good that we're doing this because we need to now move on to what's called the horizontal line test that takes care of what's called one-to-one functions. Okay? So, first of all, let me define what a one-to-one function is. Okay? Is a function where each output corresponds exactly to one input. Okay? So, get it right, because I know you're confusing it with the idea of a function. Okay? A one-to-one function is where each output value corresponds to exactly one input value. Okay, and to cover this, we have this thing called the horizontal line test. Okay, and it works the same way as the vertical line test. So if you draw any horizontal line on a function, okay, and it hits it more than once, your function is not one-to-one. Your function is not one-to-one. Okay, so vertical line is the vertical lines, right? If your vertical line hits it more than once, you don't have a function. If your horizontal lines hit it more than once, you don't have a one-to-one function. Okay, a quick thing, right, before we move on, a one-to-one function still has to be a function. Still has to be a function. So if you have something that just automatically doesn't even count it as a function, it won't even be one-to-one anyway. Okay, so let me go through some examples. Okay, determine which one of these is one-to-one. Well, first of all, determine which ones are functions, and then determine which ones are one-to-one. Okay, and we're only going to use horizontal line test and vertical line test. Okay, the first one. I'm going to draw, let me do actually the purple lines here. Okay, first of all, I need to determine function first. Okay, and if you take a look, right, vertical lines, 1, 2, 2. Any vertical line that I can draw, if it hits it once, we have a function. So every single vertical line I can draw here, right, only touches my function once. This is a function, right? But you guys take a look, if I draw that line, it just needs one, only one. If I draw that line, it hits my graph 3 times, right? This is not one-to-one. So this right here is a function, but not 1-to-1. Okay, next one. Vertical line test. All my vertical lines only hit it once. We're good. So this is a function, right? And if you take a look, right, horizontal line test, bam, bam, bam. Any horizontal line that I can draw, right, only crosses it once. We have something that's a function and that is 1-to-1. Okay, so what we're saying here, right, is that the function part says that we are every input has one output, and every output has one input. Exactly one, right? Got it? Okay. This one, number 3, vertical lines. Any vertical line I draw only hits it once. We're good. This is a function, right? But, right, horizontal line test, whoosh, whoosh, whoosh. It crosses it twice every time, right? So, not 1-to-1. Done. Okay? So if you take a look back at our definition, right? A function says every input has exactly one output. That's true for this last one, right? But every output does not have exactly one input. Okay? The way that you would be able to see this using the graph is if ever a function sort of double backs on itself vertically. Okay? You guys take a look at both of these, right? And this one, on one side it's going downward, on the other side it's going upward, right? Whenever that happens, you tend to have something that's going to be not 1-to-1. Okay? Okay, 3 more examples. Number 4. Okay, you should remember this example because we just did it. Any vertical line we draw, right, hits it twice. So this is not a function at all. Okay, and even worse, right, since it's not a function, it can't even be 1-to-1. So therefore, it can't even be 1-to-1. Done. We are good. Okay. Next one, vertical line test. Bam, 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 bam. All of these vertical lines, they only hit it once, so we have a function. But any horizontal line hits it more than once. But it's not 1-to-1. So it's not 1-to-1 here. Okay? Last one. Vertical line test. Boom, boom, boom. Every single one of these vertical line tests hits it more than once. Right? So not even a function. Right? And since it's not even a function, it can't even be 1-to-1. So automatically. Got it? Okay. All right, and I think that is it. After this, it is lecture questions. So if there's any questions, come see me at my office hours or ask me during class time. All right? Besides that, happy studying.